Okay. So yes, in the earlier classes we have discussed about the capacitor and parallel plate capacitor, and in this class we will discuss series and parallel combination, series and parallel combination. Series and parallel combination of capacitors. So before this, we will study division of charge. Division of charge means how the charge, division of charge is how the charge is divided in the circuit. In the circuit. So charge divides due to branching. Due to branching. Suppose here is a wire. Here is a wire, and now we have connected this wire, and this is the wire initially, and we have connected another wire, means we have generated the branching in this wire. So what will happen? Suppose here earlier in the wire Q1 charge is flowing, Q1 charge is flowing, Q1, here is also charge Q1, and but from this junction point, this is a junction point, from this junction point charge will be divided, this Q1 charge will be divided along this and along this. Suppose this is Q2 and this is Q3, and you should remember that Q1 is equal to Q2 plus, this is the branching. Now if I am taking a wire like this, a straight wire, no capacitor is connected, no resistor is connected, so in this wire there will be same charge, there will be same charge will remain same until the wire remains same. Wire remains same means if there is no branching. So in whole wire the charge is same. I am representing it with Q. Suppose for this wire, if I am doing like this, means I have folded this wire like this. I can do this. So the wire is same. There is no branching. So charge will also same. Here is charge 2. Here also. Like Hamza, see here. This is the straight wire. This is a wire. This is the straight wire. Okay, see here, Hamza. And suppose there is a charge. There will be some charge in this wire. And now, if I fold this wire like this, so means the charge will not change, na? Charge will not change. If I fold now wire like this, so in the whole in this wire, charge will flow of charge will remain same. But what I have done, I have connected this wire from here. I have connected this wire to some other wire. So means from this point the charge will be divided. Charge will be divided. So Hamza, I have told you this is capacitor. This is capacitor. Suppose this is C1, C2 and C2, C3. This is capacitor with capacitance C1. So here what will happen? Here charge is same across each capacitor. Charge is same because there is no branching. If I have connected a wire like this, if I am connecting a wire from here, another wire, then this charge will divide across these paths. Along these paths, the charge will divide it. And if I am connecting a capacitor like this, okay, like this is another capacitor, and this like this. Okay, so here this is C1, C2, and this is C3. Charge is Q here, and here also the charge is Q because there is no branching. But from this point, there are branches. So here the charge will be different. Charge will be different. Means here the charge will be Q2, Q3, and here again the charge will be Q2. Here again the charge will be Q3, and Q is equal to Q2 plus Q3. I am supposing it Q1. So here. So Hamza, that's how charge is divided. That's how the charge is divided. So charge will only divide when there are branches in the wire. And the physical meaning of branch is that suppose there is a wire and you connect that wire with another wire. Until the wire remains same, charge remains same. So now division of charge, now division of voltage. Now we will see how the voltage will be divided in the circuit. Division of voltage. Division of voltage. So I can write here voltage divides due to the capacitor, resistor, etc. etc. So if I am taking a wire like uh, this is the wire and this is, and this is, and so Hamza, if there is no capacitor or resistor is connected on this wire, means the potential will remain same no matter how many branches are there in the wire. So the voltage here, potential, this is not voltage, potential at point A, at point B, at point C, at point D, at point E is V, at point F is V. And if you are doing this like this, three branches are there in the wire, and this is a junction point. So there are 4 points: A, B, C, and D. Potential at A equal to potential at B equal to potential at C equal to potential at B. Because there are no resistors or capacitors. But if we charge, so from here to here the charge will same. But from this point the charge will divide. Charge will divide due to this branching. But the potential will not divide until and unless capacitor or resistor is connected. This is point A, this is point B, and the potential here is VA. Here also the potential is VA. And now if you are going like this, you now in between there is a capacitor. This capacitor will take some voltage. Will take some voltage. The voltage means energy. Will consume some energy. So here there is a change in voltage. So you can say if you are crossing this, you can say here the voltage is VV and now there is no capacitor or resistor. So I can say the voltage is V. So if I want to calculate the voltage, or I can say potential difference, I am writing in short form, across, this is C1, across C, I am supposing it's C. C is equal to BA minus PV. In the circuit, the important thing is potential difference, not the potential. Potential difference, we have to calculate the potential difference. This is point A, this is point B, this is point C, and this is point D. Here across this, the potential is VA. Here the potential is VB. Here the potential is VC. Here the potential is VD. And if you calculate, this is suppose C1, this is C2, this is C3. If you calculate V1, what is V1? V1 is voltage across C1. Voltage across C1 is equal to voltage is potential difference. VB means VA minus VB. If you want to calculate V2, then VB minus VC. Remember, VB is potential and VB minus VC is potential difference, that is known as voltage. If you want to calculate V3, that will be VC minus VD. V3 is potential across C3, means potential, not potential, V3 is potential difference across C3. So Hamza, let's see here. If you want to, if you are saying calculate the charge, so if Q charge is flowing here, then here also the charge is Q, here also the charge is Q, here also the charge is Q. Charge will not change because there is no branching, but the potential is changed due to this capacitor. And why the potential is changing? Because this capacitor takes some energy, takes some potential, okay, there will be a potential drop here. Hamza, do you have any doubt in this?
No, sir.
Okay, Hamza, please note it down. And please ask me to scroll down. Should I scroll down, Hamza?
Yes, sir.
Okay, now. Are you taking snaps or you are writing?
Yeah, I'm taking screenshots. I took this also.
Okay. Taken the screenshot of this? Hamza?
Yes, sir.
Okay, so one by one. Now take the screenshot of this. Done? Done?
Yes, sir.
You should tell me. Now take, because these notes are important. These, and please arrange the screenshots in order. Otherwise, no use of screenshot. Now please take a screenshot of this also.
Yes, sir.
Because these notes are very important for you. This was the last point. Okay, so please remember charge will divide due to branching, and potential will divide due to capacitor, resistors, etc. Okay, charge is divided here. Here is charge same. Here charge is same. And if you have any doubt, you should ask me. And there is one last case also. Mm, No, I think it's fine. Now we should start the series combination. And Hamza, one thing I want to tell you, you are taking the screenshots, but arrange these screenshots screenshots properly in an order.
Yes, sir.
Otherwise,
I labeled them.
हाँ, otherwise कोई फायदा नहीं है उसका फिर. Series combi, because uh, because this content that I am writing here, na, this content is taken from so many books. You will not get this content in a single book. In SC Verma, in any, you can take any book. Okay, so series combination of capacitor. Hamza, do you know what is SC Verma? Hamza,
Yes, sir.
I am I am saying, do you know HC Verma? SC Verma,
No, sir. What is that?
don't know.
No, sir.
Very good.
Sir, what is that?
This is the best book of physics ever published. SC Verma is a professor of, was the professor of IIT. Do you know IIT, na? Indian Institute of Technology in India. So he was the professor there, and he wrote this book at least 20 years ago, I think, 20 or 25 years ago. And till now, the this is the best book for physics according to me. If you want to get feel in physics, you should read that. Series combination of capacitor. In your school, which book your teacher uses? Which book your teacher uses? There is any book in your school? You don't know? Okay, means they are teaching you without books. So series combination, capacitors are connected like this. This is battery of voltage V. This is C1, C2, C3, and this is Cn. Mean n capacitors are connected in series. And why they are in series? Because you can see here the wire is same. There is no branch. There are no branching. So charge is same. Charge is same. Means across each capacitor, the charge will same. Across each capacitor, so charge will same. So I am writing this like charge is Q, here is also charge Q, here is Q, here is Q. But the potential is difference. This potential, here potential is V, 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 here is potential V. Here is potential V because no capacitor V, V, here is 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 V. But when you cross this, V will change. So I am taking potential here, potential difference. There is a V1 is the potential difference across C1. V1 is potential difference across C1. V2 is potential difference across C2. V3 and this is Vn. Here are n capacitors are connected in series and V1 is potential difference or voltage across C1. So accordingly, you can write V2, V3, V4 and so on. So this is the series combination of, this is a network of series combination of capacitors. Okay. Series combination. Now what we will do, you can tell this very easily. You can tell this very easily. We have a formula of potential V is equal to Q by V. We know that Q by C. Q by C. What is V here? V is potential difference. V is potential difference. Q is charge. C is capacitance. So I can write this. This V is divided. This V is divided in n capacitors. Means I can write this V is equal to V1 plus V2 plus V3 plus and so on plus Vn. And this is equation 1. I am supposing this as equation 1. Now instead of, this is Cn, instead of these all capacitors, I am taking a single equivalent capacitor. I am taking a single equivalent capacitor. And here the potential is V and here is C equivalent. C equivalent. And we have to find this C equivalent. What is this? Okay. So, and we know that charge is Q. Charge will remain same. So I can write V is equal to Q divided by C equivalent. I can write this. And now see here, Hamza. See here. If I want to calculate V1, if I want to calculate V1, so V1 can be calculated by V is equal to Q is the charge across C1 and divided by C1. Accordingly, I can calculate V2 Q by C2. Okay. And accordingly, I can calculate V2, V3, V4 and Vn Q by Cn. And now put V1, V2, V3, V in equation this. V equal to V1 plus V2 plus Vn. So what is the value of V? V is equal to Q by C equivalent, and V1 is equal to Q by C1. V2 is equal to Q by C2, and so and Vn is equal to Q by Cn. From here, charges cancel out, Q is cancel out. So what we have got? We have got 1 upon C equivalent equal to 1 upon C1 plus 1 upon C2 plus and so on plus 1 upon Cn. So that's how we calculate the equivalent capacitance of series combination. Note down, take the snaps. Okay. Now take the snap of this. Done, Hamza? Hamza, completed? Okay, take the snap of this also. And learn this formula. Should I move now? Hamza? Should I move now? Hello? Am I audible, Hamza? Hamza, now am I audible? I think you have problem in your internet. Hamza, am I audible to you? Okay, fine. So, Hamza, now it's okay. Your internet is okay now. Please tell me. Have you noted down this from here? Hamza, you are not in the meeting. You should join the meeting again. So I am sending you the message, and the mess here is saying Hamza is not in this meeting. Please speak something. Have you completed this? Am I audible to you? Hamza, am I audible?
Yes, sir.
So why the message is not sending to you? Okay. So have you completed this one?
Yes, sir. I took screenshot.
This one also?
Let me check. Yes.
This also na?
Yes.
Okay. So in the series combination of capacitors, the equivalent capacitance is calculated like this. Okay. So if two capacitors are connected, if two capacitors C1 and C2 are connected in series, this is C1, this is C2, and this is not the capacitor, this is the battery. I'm having the voltage. So here the C equivalent, when you apply this formula, you will get C1 C2 divided by C1 plus C2. Please remember this formula. We will use this in the questions directly. It will save your time. So take the screenshot. Then we have some terms that we will, okay, we will, some terms that so we have this circuit. I'm just modifying this circuit. This is Cn, this was Cn. Yeah. This is the same circuit, not the modified circuit. So here, from this circuit, there can be some questions that can be asked. Number one is, total voltage across circuit. Total voltage across circuit. VT. V total is equal to total voltage is this V, simply, no problem. Now voltage across each capacitor. Voltage across each capacitor means V1 Q by C1, V2 Q by C2, as charge is same. And like this, you can calculate Vn Q by C. V is equal to charge upon capacitance. Now, total charge in the circuit. Total charge in the circuit. I am representing it with Q. Q, this I am representing it QT. So QT is equal to Q. If someone is, and if you want to calculate total charge, so how will you calculate total charge? Charge is equal to, you will take C equivalent into V. Q total is equal to C total. C total means C equivalent into V total. V total is V. Number 4 is charge across each capacitor. So charge across each capacitor means Q1, Q2, Q3, Q4, and all the charges are same here. Q1 is equal to Q, Q2 is equal to Q. So you can write Q1 is equal to Q2 is equal to Q3 is equal to and so on is equal to Qn is equal to Q. Energy stored in each capacitor. And Hamza, we have three formulas for energy. I represent energy with U. First formula is Q square by 2C. Second formula is half CV square. And another formula is half QV. You can apply any of the formula to calculate the energy. And I am applying here. This is just okay. So here U1 is equal to Q charges same 2 into C1. Energy stored in capacitor 1. Energy stored in capacitor 2. Q2 divided by 2 C2. And you can also write this as equal to Q1 into V1. Q1 is Q and V1 is V1. Means no need to write this. I'm just telling that you can calculate the energy in this way also. So accordingly, you can calculate the energy for nth capacitor. Charge is same. Okay. Sixth point. Sixth point is total energy stored in the system or circuit. Total energy stored in the circuit. Total energy in the circuit means I am representing it U suffix T. So U suffix T is equal to U1 plus U2 plus U3, because energy is the scalar quantity and we can add the energy directly without considering the direction. So U total is this. U1 is Q square divided by 2C1 plus Q square divided by 2C2 and so on, Q square divided by 2Cn. So U total from here, what is common here? Q square by 2, here Q square by 2 common, Q square by 2 common. We will get 1 upon C1, 1 upon C2, 1 upon C3, 1 upon Cn. And Hamza, what is this Hamza? What is this? Please tell me, Hamza. अरे यार, अरे ये देखो यहाँ पे ये लिखा है ना 1/C1। तुम्हारा ध्यान कहाँ है क्लास में? तुम यू हैव टू
I
फोकस
was
ना।
disconnected when this was.
ओके, so you should tell me ना. You were disconnected. I will tell you again. So here you can see that this is C equivalent is equal to 1/C1, 1/C2, like this. Okay. So instead of this, I can write 1/C equivalent. So U total is equal to,
Q square by C equivalent into Q.
yeah, very good. C equivalent. Now earlier, but you know the formula of energy, like I am telling you how to write this. You know that if you calculate the energy, you write the formula Q square divided by 2C. Up, if you want to calculate the energy for series combination, total energy for series combination, you know in series combination charge is same, so write charge as is this. This is 2 and you want to calculate total, so here will be total capacitance, means equivalent capacitance. You can write like this. Hamza, please note it down. And I have done nothing here. These are capacitors. These are connected in series. Why in series? Because charge is same here. There is one wire connected with one wire only. But the potential is different here. Okay. And we finally got this formula. Finally get this formula. You have to remember if you want to calculate. But this is very easy thing. I have done nothing very extraordinary here. I have done just the calculations or put the values or formulas. So please, you have completed this. You have completed this.
Yes, sir.
Okay, good. And Hamza, remember one thing. You are taking the screenshots, but it is my humble request from you that arrange these screenshots accordingly. Okay, now take the screenshot of this also. Take this.
Yes, done.
Okay. Take this also.
Done.
Very good.
Yes,
Okay,
sir.
okay, okay. Fine. Fine. Take a break of 1 minute and try to think the formulas. And today I will take your class till 10:45. maybe. Take break of 1 minute or 2 minutes. Just relax your mind. Okay. I don't want that I am teaching you and all the things are going above your head. And what is the use of that? There is nothing different here. You know about the capacitor. What is capacitor? You know about what is energy. You know about what is charge. You know about what is potential difference. I have told you. We know all the things and we have to connect the dots correctly. Okay. We have to connect the dots. These are dots. Suppose these are dots of your physics. Please listen this. Listen this. These are the dots. Dots means dots of your physics. Suppose you have studied physics one time here. In the order you are like from the January you have started and it's February, March, April, and like this you have studied. And this is first chapter, second chapter, third, fourth, fifth, sixth. These are all the other chapters. And we have to make a rectangle if we want to successful rectangle. This is just the condition. Someone says if you will uh, if you will draw the rectangle means if you produce the rectangle then you will be successful in life or in the examination. So what here you have done, are you listening Hamza carefully what I want to say?
Yeah, yes.
Okay, very good. So actually you have started from here, you are going in direction, in some direction you have gone here. So what does I mean when I am saying connect the dots? Connect the dots means first chapter is related with like this. You have to do like this. You have to do like this. You have to do like this. And you have to do like this. You have to connect the dots properly in order to form the rectangle. Means in order to get good marks. Not I am not talking about the marks. I am talking if you want to successful in your life, if you want to become anything. Anything means if you want to a good player, if you want to a wrestler, if you want to a basketball player, if you want to a TT player, at every stage you have to follow this rule. You have to first work, you have to work, and after that you have to connect the dots. Connecting the dots means analyzing your work, what you are doing, and accepting your mistakes and learn from those mistakes. And this thing can be done when we are doing this in a particular direction and with a particular speed. So these things are very, very important. I am not saying this physics is very, very important. I am saying how to how to do the work, how to how to achieve your goal is important. For for me, teaching is important, physics is important. Okay. And you have to give the examination of 12th class. So I think for you also there there will be a little bit space in your heart of this subject, little bit. Maybe you are not understanding this 100%. Maybe if you are not, no one can understand physics 100%. Not even physics, any other subject you can take. And best are those according to me who try their best. If you are in the class of 1 hour 30 minutes and your mind is somewhere else, you are thinking that you will be going to watch a movie, or you will go to play some game, and you will do some other thing, then I think that is not good. We have to focus at a point, at a in a particular time zone. Like for 1 hour 30 minutes, you should think that I will give my best, whether I will understand 10%, 20%, 100%. And this will happen when you study the notes, previous notes, that when you recall your previous classes. Okay. When you recall your previous classes, and one day you will find everything is connected. Like capacitor, how capacitor is connected with electric field, how electric field is connected with charge, how charge is connected with potential, how potential is connected with work, how work is connected with energy, how energy is connected with force. You will find one day this thing. Today I am teaching you, maybe tomorrow I will not teach you. Maybe there can be the chances that there will be some other teacher also that will teach you this subject. I am not the best teacher. I am not saying that I am the best in teacher in this world. There are many other teachers which are far better than me, but I am just saying that you should give your best, then I think you are the best. Okay, Hamza, have you understood something?
Yes, sir.
So this is the last question, and after that we will discontinue this class. So here two capacitors are connected in series. See, the series combination is like this is one wire. On this wire this capacitor is connected, on the same wire this capacitor is connected, and the capacitance of this connected is 5 microfarad, and this is 10 microfarad, and here is 10-volt potential battery is connected, and we have to calculate C equivalent means equivalent capacitance. I'm writing here. Equivalent capacitance. That is total voltage in the circuit. Total charge, charge in each capacitor, voltage across each capacitor, energy stored in each capacitor, and seventh is total energy stored in the circuit. We have to find this. So what I am going to do here, see here, I will take a single equivalent capacitor, sorry, and I will calculate C equivalent. C equivalent is equal to, I have written the formula for two capacitors here, where I have written this C1 into C2, C1 plus C2. C1 C2 divided by C1 plus C2. C1 is 5, this is 10, this is 5 plus 10, this will become 50 divided by 15. Okay, this will become 10 by 3 microfarad. 10 by 3 microfarad. So our first answer is this. Answer first is this C equivalent. And this is 10 volt. And charge is same. Across each capacitor, charge will all remain same now. Charge here Q. Here also the charge Q. But the potential is different. Here is potential V1 across this. Here is potential V2. First question is solved. Total voltage. This is first. Second. Total voltage is VT. VT is V. And what is V? 10 volt. Total voltage is this. Total voltage is this. Now they are asking number third. Total charge. Total charge. Total charge. Right. Total charge. I am representing total charge with QT. Okay. Total charge. is equal to Q. Total charge is Q. Charge is same everywhere. So total charge is equal to total capacitance. Total charge is equal to total capacitance into equivalent total voltage. Yeah. Total charge, total voltage into equivalent means equivalent capacitance. So Vt is given by 10 and equivalent C equivalent is 10 by 3. This is in microfarad. We have to convert this 10 to the power minus 6. This will become 10 to the power minus 4 divided by 3 coulomb. Now they are asking charge in each capacitor, and we know that charge in each capacitor is Q. Charge in each capacitor is Q. Charge in each capacitor is Q and Qt is equal to Q. So third question is charge in each capacitor means Q1 is equal to Q2 is equal to Q, and that is equal to 10 to the power minus 4 by 3 coulomb, because charge across each capacitor in series is same. Question number 4, charge in each capacitor. Fifth, voltage across each capacitor. Voltage across each capacitor. Voltage across each capacitor means voltage across capacitor 1. V is equal to charge across 1 divided by capacitance across 1. Charge across 1 is Q1. Q1 is equal to 10 to the power minus 4 divided by 3. And C1, what is C1? C1 is 5 into 10 to the power minus 6. Hamza, tell me the answer.
Yes, sir.
Okay.
Can
No
you
need,
repeat
no
this?
need. I will do this. This 6 will go up and this will become 100
Yes.
and this will become 15. So I can write from here 5 to the 20, 20 by 3 volt. Okay. And V2 equal to Q2 divided by C2. And Q2 is again 10 to the power minus 4 divided by 3. And C2 is 10 into 10 to the power minus 6. And when you will calculate this, you will get 10 by 3 volt. Fourth question.
Answer is 3.3 volt.
Okay, no need to divide this further. Okay, you can write this answer also. Okay, it's also correct. If you want, then you can do. But fifth. Voltage across each capacitor we have calculated. Oh, this is sorry. First, second, third, and this is fourth. This is fourth. This is fourth, and this is fifth. This is fourth. This is fifth. Now in sixth, energy stored in each capacitor. Energy stored in each capacitor. Energy stored in one capacitor means Q1 square divided by 2 times of C1. Simple. Q1 square, we know that what is Q1 square? Q1 square is 10 to the power minus 4 divided by 3 whole square. This into 1 upon 2 times of C1, 2 times of C1. C1 is 5 into 10 to the power minus 6 minus 6. When you calculate this, you will get this will be 10 to the power minus 8. This will become 10 to the power minus 2, 10 to the power minus 2. Okay. And this will become 30. Sorry, 90 joule. If you want to calculate U2, Q2 square divided by 2C2. Now Q2 is 10 to the power minus 4 divided by 3 square 1 upon 2 into 10 into 10 to the power minus 6. When you will calculate this will become 180 10 to the power minus 2 divided by 180 joule. Okay, Hamza?
Yes, sir.
And if you want to calculate the total energy stored, 7th point. Total energy stored, you can first calculate the energy like this, U1 plus U2, and you will get the answer. 10 to the power minus 2 by 90 plus 10 to the power minus 2 divided by 180. Now here 10 to the power minus 2 is common. Here 180 is LCM. Here 2, here 1. So from here you can calculate 3 by 180 into C. Okay. And when you will cancel this out, this will become 10 to the power minus 2 divided by 60. This is your total energy. Or total energy you can calculate by some other method also. If you want to calculate total energy, you should not do this. You should do like this. Charge is same divided by 2 times of C equivalent. Now put the value of charge 10 to the power. What is the value of charge? Minus 4 by 3. Minus 4 by 3 square into 1 upon 2 into what is C equivalent? C equivalent is 10 by 3 microfarad. So put here 10 divided by 3 microfarad means 10 to the power minus 6. And when you calculate this, you will get the result, same result, 10 to the power minus 2 divided by 60 joule. So there are two methods. Is it right, Hamza?
Yes, sir.
So this kind of numerical you can get in your examination. So please note it down, Hamza.